Hello, my name is Daniel Schwartz, and I'm going to talk about TDD for PLSQL. Now, first of all, we're going to be talking about why we need TDD, what that is good for, very, very briefly. Secondly, I'm going to present what tools I'll be using. And then the example, I'm going to be talking about prime numbers, and then we're going to go into coding now. First of all, TDD. Why do we want TDD? Right. The Wikipedia page on TDD has a huge amount of text that outlines the benefits of it. I suggest that you go and read it if you feel that that is something that you need to do. Right. I would like, though, to get your attention to how we actually do TDD. Right. We do a check, we add a check, right? We run the check, and obviously, since there is no code yet, it will fail, right? We write some code so that our test is actually working, and then we run the tests again until it works. Then we clean up, then we do some refactoring, and then we start again, right? And this is what I would like to do when we get to the point of writing actual code. Right. Back to the agenda. The tools of the trade. I'm going to show you guys the directory where I have downloaded. First of all, let's go. GDK19. This is the Java that I'll be using, right? Yes, I am using Java. There are a lot of benefits. I'm going to explain why that is a good thing. Obviously, I'm downloading a database for my purposes, Oracle Express, reasonably late version, SQL Developer in order to interact with that. For SQL Developer, I need JDK 17 for some reason. It wouldn't work with 19. I will also be using Apache Maven for this purpose as well. Yeah, and Eclipse to write Java code, right? So the idea here, as you might be figuring out, is that I'll be using JUnit in Java in order to write the tests for PLSQL. That's the whole idea. Right. There are other things here for, I want to record this video. This is something else, thing from my mouse or something. Moving on. Prime numbers. Let me walk you through the piece of code that we'll be writing. That's not it. This is it. Right. The prime number algorithm. What we want to get is a function that can take a number as an argument and return back like whether it is a prime number or not. Now, a prime number, as you may know, and here you might need to pause the video, is a number that can only be divided by 1 or itself. So here is a very, very short list of known prime numbers. Right? 3 cannot be divided by 2 because you'll get all kinds of decimals. 5 cannot be divided by neither 3 nor 2 nor 4. Thus, 5 is a prime number. Now, I have a parenthesis on the 5 saying that this is the biggest known prime because I'm going to actually be creating a list, right? A table, if you will, with all these prime numbers. And 5 will be, in my example, the biggest known prime number. Right? Now, the algorithm I'll be using is, well, this. If the number that we want to look at, whether it's prime or not, is smaller than 1, strictly smaller, then it makes no sense. There will be an error, right? Now, if the number is in between 1 and the biggest known prime, right, between 1 and 5, then we can actually just look in the table. Does it exist in the table? If it does, well, then it's prime, obviously. Now, knowing that 5 is the biggest known prime here gives us the ability to know if any number between, well, actually, yeah, 6 and 25, because 5 times 5 is 25. With those three numbers, we can actually safely answer the question, is a number between 6 and 25 a prime number? So let's say 17, for instance. If 17 is not divided or divisible by 2, 3, or 5, then 17 must be a prime number. Now, there's some math behind that, and yeah, you might want to look it up. I can, or you can just trust me on that. Now, if the number is bigger than 25, then we need to have some other way of figuring out whether that number is a prime number. So we need to produce enough prime numbers, go and find them, so that the number that we want to look is actually smaller than the root, the square root of the biggest known prime, right? So in our case, if we want to look at, for instance, 77, right, then we would need the biggest known prime to be, well, at least 11, actually. Right. So we would need to look at, like, is 6 a prime number? Is 7 a prime number? All the way up to 11. And then we rerun the function, and then, yeah, we can go there. Now, I have here a how to produce these numbers, but we won't go that far. Cool. Some light coding. Excellent. For that purpose, I have Eclipse, and I will go ahead and create a Maven project, right? And I'm going to call my project sc.rtz.primes. And this is an example. Well, primes.test maybe, right? Now, it all looks as if I'm about to code Java here, but actually I will be coding PLSQL. Right. So I got my example code here. I would like this to be Java 19, actually. For this purpose, I'm going to pause the video. Give me a sec. And we are back. Yeah, during this time, I have actually added some dependencies, and I've added the properties to make my project to be a proper Java 19 project. Right, let's look at my dependencies. First of all, I'm using JUnit, so thus adding the test scope here. So I am adding the Oracle JDBC driver, right? Because it's an Oracle database that we're talking to. And finally, I'm adding the PLSQL JUnit test thingy that we'll be using in order to test our code for prime numbers. Right, let's jump right in. We'll go ahead and create a class, and we'll just give it a package here, sc.rtz.primes, and yeah, let's say prime test. Cool. Here we go. We're adding a test. Public void test -1, for instance. Right. So we are going to try to see if -1 is a prime number. Now, the first thing that we'll do is to go ahead and create ourselves a so-called context object. So try ps test context dot create, and here we want to know what schema will this code be in. And I think that I actually went ahead and created a schema for this already, named actually primes schema. So we'll go ahead with that. And here we go. Cool. Now, what's going to happen when I do this is that the framework, the PS test context here, will go ahead and create another schema, right, where it can control whatever code I've written in a more fine granular way, right? Now, my code will obviously be all entangled with tables and other functions and procedures, right? But when we do the test, we want to actually isolate the piece of code that we want to test, right? So we need to make some kind of alterations to it, right? So we will go ahead and say context dot prepare procedure. Right. Now, actually, I wanted to prepare a function. Right, so we are preparing the function here. So we prepare the function. The function exists in the primes schema. In the package name, primes package, and the method name is prime. Cool. Now, you know, and I know that that does not yet exist. But this is the beauty of it, right? That we write the test as if it exists, right? Create a function. It's a function. Oh, actually, like that. And then we will invoke it. Right, and this is a list of parameters. So list of, and then we need to provide a parameter. Now, here we go, that class, and it's an out parameter. The first parameter in a function will always be the return value, right? And here we're actually, I mean, it should be Boolean. However, I am going to return a number, 0 or 1. I'm actually passing in null here, right? And the other parameter will be an int parameter, but also a number. And here that my number will be, as you know, -1. The result of calling invoke is a list of parameters. In fact, it's actually very much the same list I provided as an input. So yeah, I can actually then go see, is prime will be result dot get 0, which is my first value, right? Let's do, you're not supposed to do this, I'm going to do it anyway. Sysout is prime, just to see what's hiding in there. Cool, let's run this test then. Oh, it didn't work. Wonder why. Initialization error. Missing resource. That's because we don't have the resources. Cool. And this is the, we need to add a file here. New file. Yes. PS configuration. Here we go. And I actually prepared such a file. Let's see. Here we go. So this is our JDBC URL. This is my password, and this is my user. And this needs to be a sys, DBSys user, right? So if you can't get a hold of that for your database, then yeah, you might be in trouble. Let's try this again. Oh, right. We now are creating a temporary schema. Oh, right. Yes, this is not my username and password, actually. The sys is correct. However, my password was not correct. Here we go. Let's try this again. All right. So what we've just done is we created this temporary schema, right? We've added a lot of different grunts to it, so we can use it. And then all of a sudden we simply removed it. Now, what does the test say? Method primes package is prime in schema. Primes schema seems to be missing. Cool. Now let's go ahead and create it then. And for that purpose, I'm going to put these two editors side by side. First of all, we need to create a package. And it's going to be called, you guessed it, primes package. Cool. Here it is. Let's just compile it and run it, possibly. I don't know. Yeah, we compiled it at least. Oh, no public members. So let's add a public member then. function is prime. I'm just doing this to get the name of, yeah, we want the returns thing, obviously. Yep, something like that. So I'm not very good at PLSQL. You might have figured that out. Right, so my first parameter will be a number. So I got that in the wrong order. And this is also a number. Cool. So now I need the body to this as well. Right, here we go. So now we are returning null, right? This is by all means a valid implementation, right? So let's run the test again. Let's see what happens. Okay, it failed. And now it says that is prime in prime's schema seems to be missing. Prime's package and its prime schema, and I'm just trying to figure out here if I've spelled something differently or something. So I'm going to pause this. All right, and I'm back. So yeah, found out why we couldn't find the code, and it's because my schema name is actually C ## primes schema. Now, why that is so, I don't know. There is some Oracle magic going on here. Someone please write in the comments why that must be so. Cool. Let's run this again. All right. And we just wrote our value here. And the value that we got was 0, right? Now, I would say that this is not really the behavior that we want in the code. You could argue that -1 is not a prime number, right? But in fact, it's altogether simply just wrong to even ask the question. So I would like to expect some kind of exception here, right? So let's start with an if statement here. If candidate is lesser than 1, right? Then we want to raise an exception. Raise. Well, what's a good exception to raise here? Let's see, here's a good list. Access into null. Now, what we want to say is probably invalid number, actually, because this is an invalid number. -1 is an invalid number in our context. Invalid number. There we go. And then we'll close the end if. Something like that, I think. Or do I need a space? Probably need a space. Compile this, and let's see what happens over here then. Run. Yes. Cool. And what do we see? All right. We got an SQL syntax error exception. So that is then an expected exception. So we'll simply do the following. Catch and here we want to, in the best of JUnit manner, actually assert that we are getting this Aura error saying 01722, right? In Swedish it says invalid number, right? Ogiltigt number. But we're going to be looking at the Aura number because it all depends on, yeah, so many factors, what language it will use. Right. Assertions. Assert contains possibly. True. Assert true. Let's go with that. E.get message contains Aura. Here again, let's have a look. 01722. Right. And what we might want to do as well is to say here that if we make it to this line, assertions.fail, and here we might want to write why we failed. Cool. And let's run this again. Excellent. Right, so now we know that for invalid numbers, our function will behave in a proper manner. Now, let's look, let's have a new test. Right? We'll just right? Still, we want to have these prime numbers, right? But this time we want to check is 2 a prime number, right? And now we're not expecting to fail if we get to this line. If we get a syntax error thrown at us, then that would be wrong. So we'll just simply not catch it. Right. Let's run this again. All right, we got a 0, which means that in my mind that this is not really a prime number, but let's go ahead and make that assertion anyways, right? So the expected value will be 1, and the actual value is value dot get value dot get value. Is this a good way to do it? Get value dot get value? Probably not. This might need some more work. New integer 1 actually. Oh, I don't like that. Cool. Let's run this again. Oh, this is the wrong name. Right, test 2 failed. Now, before I move on, I want to just spend a few words on like the different tests that we do. Now, as I said in the beginning, when we create the context object, we actually create a different schema, right? So meanwhile, while this is running, there is another schema on the side that has been created. So yeah, so when we exit the try statement, then that schema gets removed. So we've actually created that same schema twice now. Now it's a local DB. It's quite fast. I mean, it's still pretty fast tests. Right. This failed because we were expecting 1, but we got 0. Excellent. That's the way that we want it, right? Now, let's do some real PLSQL coding. Now, if 1 is smaller or equals to our candidates, and the candidate is smaller or equal than our biggest known prime, then we're doing stuff null for now. And if, right, the biggest known candidate, now we need a variable in here, right? And the way to do variables is now in Java this would be easy. I think that is the correct way to go about it. Cool. Yeah. Oh, we got lowercase code everywhere. Now we need to provide a number for this biggest non-prime. So let's go and do select n, actually max n into biggest known prime from primes. Right? So it's telling me here that, oh, that table doesn't exist. Fair. I need to create it. So we want a table named primes. We want a column named n. It should be a number and should not be null. Could be considered to be a primary key actually, because we don't expect duplicates. And let's go. I think I just made a poo-poo because yes, I got it wrong. Let's drop this table. Yeah, that's the name. Column is n, number and primary key. Cool. Here we go. And let's add some data into it. So first number will be 2. Second number is 3. Third number is 5. And let's commit that. Cool. Right, which actually makes 1 an invalid number. I'm going to change this to lesser or equals and change that one. So, yeah. Let's recompile this. Yeah, works. And now we are going to look if that number actually does exist. So I'm going to have another variable, results, and number. Cool. So here I want to know, is the candidate actually in my table? So the way to do that is select count. So we're selecting basically the number of items in our list that are equal to our number. Select count into results where n equals candidate. Right. Now you know and I know that this will actually select into, from maybe, from primes. And then we can return results. Cool. Yeah, let's run this again. Okay. Oh, the table named our table does not exist in the test schema. So what we need to do in order to get that fixed is to actually mock that table. Let's use the context. mock table, right? And the table name is primes, and we're going to add a row, right, with a type value number, let's say 2. Oh, that's one row. Another type value. Three. And 5. Cool. We don't really need any more prime numbers, right? Actually, for my purpose, it would be enough just saying that 2 is a prime number. Here. That would do it. Let's go ahead and run it. Yay! So, as the TDD says, we've added a check or added a test. We've run all the tests. So if something fails, we do some work. We run all the tests again. So everything actually is running, right? And now we clean up. So let's do some refactoring. First of all, I want to have this as a constant. Let's go ahead and say extract constant and is prime number. Cool. Yeah, that should do it for now in the Java code. In PLSQL, I would like to actually make a different kind of I would like to say that this array's invalid number should be at the very end of this, right? And then we simply skip this. That means that if we would test this with if we would run it with a number 22, we would get an invalid number because right now this algorithm is not really equipped to handle anything bigger than the biggest known prime. So let's run our, let's compile this first. Let's run our tests. -1 is not working. And that is because we're actually executing this even in the -1 example. So we need to mock the table. Let's go ahead and run it again. And it works. Now, from a prime number aspect, I would like to show you that my algorithm is excellent and it works. But from a TDD point of view, I think that this is definitely, it shows the potential and also how to do TDD. Now, a few words on why the test framework is not in PLSQL but rather in Java. There are a number of reasons for that. First reason is that I'm more fluent in Java. That's actually why it ended up being Java. But there is Other benefits to it, most building frameworks like CI/CD pipelines will actually execute these tests in an automatic way so that you can get the tests that you build for your code executed automatically every time someone checks in code into the versioning system. Um, so yeah, with that said, then this is the test framework. We can mock things and we can run things automatically. Um, thank you very, very much for watching. And if you have comments, please add them below. Thanks.